Now, after going through the dependent and independent events, we will learn about non-mutually exclusive events, and especially when we have got more than two events. So first of all, we look over here. We have got two events, A and B, and they are not mutually exclusive. When they are not mutually exclusive, as we have discussed earlier, then we have to subtract this intersection of the events A and B in order to avoid the repetition, because this A and B, this part has already been added. When we added A and B, this part was already added, so we have subtracted this one to get rid of this. It is shown over here in the Venn diagram as well. Now, if we talk about three events like A, B, and C, and we take union of these three events, which are not mutually exclusive, then in that case, probability of A plus probability of B plus probability of C minus same as probability of A intersection B, probability of B intersection C, and minus probability of C intersection A. Then we have probability. Then we have to add probability of intersection of A, B, and C. Now this is a little bit confusing over here, by why we are adding intersection. So why do we add this intersection? The reason is that when we subtract this A intersection B, B intersection C, and C intersection A, we subtract this part A intersection B intersection C thrice instead of twice. So therefore we add this to correct the result. Now this statement is not very clear. We will go through some examples. First of all, numerical examples, then we will drive this formula or whatever equation, whatever you call it, and then it will be we'll have better understanding why do we add this A intersection B intersection C. So first of all, we look at an example. Here we have got, it is not based on probability, it is just an example of simple sets. In a junior class, the number of students in electrical engineering EE is 100. In math class 50, and in computer science class 150. Among these 20 are taking both E and double E and MA, means 20 students are taking engineering classes, electrical engineering, double E, and maths classes, and 25 are taking double E and CS, and 10 are taking MA and CS, and 5 of them are taking double E, CS, and MA. Means there are 5 students who are enrolled in all the 3 classes of double E, MA, and CS. So we have to find the total number of students in the junior class. So this exercise will actually help us to understand how we distribute the figures in the Venn diagram. So from the information given over here, we just assign the letters to these sets and the numbers. So let's say double E is called set A, it has got 100 students, and set B has got 50, and set C, which is CS, has got 150 students. When we say that 20 students are taking both double E and MA, actually it means that these students are common between A and B section. So students taking both E and MA is equal to A intersection B is equal to 20. Students taking both double E and CS is A intersection C, 25. A student taking both MA and CS is B intersection C is equal to 10. And students taking double E, MA, and CS is equal to A intersection B intersection C, because it is common among all the 3 classes, which is the number of students is 5. So total number of students is A union B union C. So how do we draw the Venn diagram? If we place the numbers as we have just written over here, 100, 50, and CS. So in A we have written A, and B we have written 50, C 150, and these are the intersections. So intersection 25, 20, 10, and the common one is 5. If we write it like this, we will get the wrong answer. This is not the correct Venn diagram, because uh, the total number of students in A, in set A, must be 100. But if you look over here, then it goes above 100, because if you add 100 plus 25 plus 5 plus 20, it becomes 150. So this is not the correct way to place the numbers. So how do we write the quantities, or write the numbers in the Venn diagram? First of all, we write the very first value which is common between A, B and C, that is 5. This 5 is common for all A, B and C. These 5 students are enrolled in all these 3 classes, A, B and C. Then what we do is that we write number over here. This number over here is actually nothing but subtracting this value from this value. Actually, this 20 over here, this A intersection B, is actually this whole area over here. This area is A intersection B, and this area is A intersection B intersection C. We already have written 5 students over here. We know that the total number of students in this area cannot be more than 20. 5 students are already over here. It means the remaining students are 15. So the area in the student number of students in this area, I look at my cursor which I am drawing, in this area the number of students in this area is 15. So altogether in this area, A intersection B, it is 15 plus 5, 20. Now for this area, we have total number of students is 25. This is A intersection C. Same as before, we have got 5 over here, so the remaining students are 20. So in this area we have got 20 students. Now we have to write the remaining students over here. So what are how many students are remaining who are taking only and only double E classes? They are not enrolled in any other class. They are just enrolled in double E class are 60. The rest are either 5 are out of 100, 5 are enrolled in all the 3 classes, 15 are enrolled in A and B both, 20 are enrolled in A and C both, and 60 are only enrolled in class A or double E class. Similarly, here we have got 5 students. How did we get these 5 students? Because we know that in this area we have got 10 students altogether. So 10 minus 5, we have got remaining 5 students which are in this area only. So I think it is very clear. Similarly, we have got this figure, the remaining number 5 plus 5 plus 15 minus 50 gives us 25, and here 20 plus 5 plus 5 is 30, which is subtracted from 150, and we get 130 over here. You can see 120, sorry, 150 minus 30 is equal to 120. So this one tells us how do we look at the areas. So A intersection B is which area? This is the A intersection B. This area is A intersection B. This area over here is A intersection C. This area over here is B intersection C. And this area over here is A intersection B intersection C. And to find the values of this area only, what we need to do is that we need to subtract this area. So when we will subtract this one from this one, the A intersection B, this area, then we will get figure for this area. So this example will help us to understand further. This is something which I have already told you in the previous slide. It is just that it is repetition. The students who are taking double E course only are 60. Students taking MS only are 25. Students taking CS only are 120, and students taking E and MS are 15, and so on. You can read this yourself. So now we will go in more depth that how do we get this this P intersection B intersection C, which is added in this one, how do we get this term over here? So to understand this, let's have a look at this Venn diagram. We have color coded the areas so we can identify the areas easily. So first of all, we have to understand the union of these areas. So how do we get, for example, first of all we have to understand how do we get this red area only. So actually we have seen this. We have what we did over there in this example over here. What we did is that we added these values over here and subtracted from the total value, and we got this value 60. So actually what I'm talking about is this is the same. Red area or only area means how do I get this figure over here. Only A means this red area. Only A or red area is equal to A intersection B prime intersection C prime, or B naught intersection C naught. A intersection B is this whole area, pink plus white, as I told you before over here. This is our A intersection B, this area 15 plus 5. Similarly here, our intersection A intersection B is this area, and A intersection C is this area, yellow plus this white area, which is intersection B intersection C. So white area is A intersection B intersection C. So if we just simply want to get this A only, so what we do is that we subtract A intersection B and A intersection C, and then add A intersection B intersection C. So if you apply the same over here, for example, we want to get over here. So what is the value over here? 60. So 100 minus, what we do is that we take this all value, which is 25. Here it is 20, because this is what A intersection B and A intersection C are. So 25, and here we have 20, so it is 45. 45 minus 45, 100 minus 45 is 55, and then we add A intersection B intersection C, which is this 5, so we get 60. So what we have done over here in this example previously over here, we are doing the same over there as well. The only difference is that the way we have written it. So here what we are saying that we add this value and this value and this value, and then we subtract it from 60. There we are saying that we subtracted this value and this value and then added this value. The both ways we will get the same result. So, and in order to get the intersection, so let's have 3 sets ABC, as we have just already have this one, and A intersection B intersection C prime, this area. We are talking about this area only now, this area. So this area is intersection B, but excluding C. When we'll exclude C, then we'll get what we'll get. We'll get this area in pink. So, so what we need to do is that we simply take this whole area A intersection B and subtract this area from that. So A intersection B minus A intersection B intersection C will give us this area. It is very simple. You can see it from the graph or figure as well, that if you want to get this area in pink only, then what you need to do is that you simply need to subtract or remove this white area from this whole area over here. So this is actually what we have done over here. We have subtracted A intersection B intersection C from A intersection B. Let's have three sets A, B and C, and A union B and C. Now how do we get the equation that we are talking about so far and we are trying to understand? So actually the union of A and B C is simply this red only area, this B area, only B area means this blue area, this C only area, which is this green area, this yellow area, which is only A intersection C, this light blue area, which is B intersection C, and this pink area, which is A intersection B, and then A intersection B intersection C. When we will add up all these areas, then we will get A union B union C. So using the previous knowledge on these two slides over here, we say that A is equal to A intersection B prime intersection C prime. We already have driven over here this one, this area A over here is A intersection B intersection C intersection A intersection B complement intersection C complement. So we have that what we have already discovered. We have just written over here A intersection B complement intersection C complement. Then we have B is equal to B intersection A complement intersection C complement. This is the same thing. So these three equations are easy to understand, and over here, as we said before, that this area over here, this pink area, is nothing but A intersection B intersection C complement. You can see over here A intersection B intersection C complement. So after writing these values, and I have color coded these text as well according to the colors of the areas in this Venn diagram, so it is easy to correspond. Now we have simply replaced these values what we have found over here into this one. We have just plugged in these terms over here. So after plugging in the terms, what we get is this term. I'm not going to read this all out. You can pause the video and you can tally it yourself. So after getting this equation, what we do is that we are going to replace A intersection B intersection C with this value. This A minus A intersection B minus A intersection C plus A intersection B intersection C, we have found it over here, and I have explained you how did you get this one. So simply we replace these three terms with these three terms, and what we get over here is this equation. After that, we will replace these three terms, A intersection B intersection C complement and A intersection C intersection B complement and so on, with these three terms over here, with terms like this for all of them. So what we do is that we replace these one with this one, as you can see. And again, I have color coded them so you can correspond which one is being replaced with which one. And after replacing these terms, we get this final term over here. Actually, it is not final term, but a term before the final term. And we will just simply use the algebraic mathematics, and we will just simply cancel out the terms of opposite signs. After cancelling out the terms having opposite signs, what we get is this one: A plus B plus C minus A intersection B, and minus B intersection C, and minus C intersection A plus A intersection B plus B intersection C. So you can see that it is very easy to understand now that A union B is what? This area over here, this area over here, this area, intersection B completely, this area over here, this over here, and then we add this one because we have subtracted these areas more than twice. So finally we'll get this area, add it up, and we'll get the correct answer.